Hi guys, just to refresh you that we are doing thermochemistry and now we are all familiar with enthalpy changes, molar enthalpy, what do you mean by enthalpy, delta H naught values. Let's do some applications of enthalpy changes. Let's do a question related to molar enthalpy change. We all know what is molar enthalpy. Let's understand the representation of molar enthalpy. Molar enthalpy is delta H naught. This naught represents molar enthalpy change. As we know that molar enthalpy is nothing but enthalpy change required for 1 mole of a substance. This is just a simple definition of delta H naught or molar enthalpy. Now the question wants us to find out the molar enthalpy. Let's read the question. The complete combustion of benzoic acid is represented by the equation below. You do not have to memorize any equations. Equations will be given to you. So the equation for benzoic acid looks like this. This represents our reaction for combustion of benzoic acid. This is benzoic acid. Combustion means it is burning in the presence of oxygen, gives you CO2 and water. And since combustion is an exothermic reaction, it will release this much amount of energy. And we can see since the number is put on the right side, that means it is an exothermic reaction. Now the question wants us to find out standard molar enthalpy of combustion. We know the representation of standard molar enthalpy of combustion is delta H naught C. Delta H naught C stands for molar enthalpy of combustion, where C is for combustion. We are looking for molar enthalpy of combustion, so we would just see that this is the combustion reaction and the enthalpy of combustion reaction is given to you as delta H equal to 6456.4 kilojoules. So we are looking for this, but if we rewrite this reaction, we can write it as 2C7H6O2 plus 15 oxygen. So if I represent it as a delta H value, so I would just write on delta H on side as minus 6456.4 kilojoules. Now this is the enthalpy change for combustion of 2 moles of benzoic acid. I want to find out molar enthalpy, and molar enthalpy is for 1 mole. So that means your molar enthalpy of combustion is nothing but the enthalpy change divided by the number of. In this case, the number of moles are 2, so all we have to do is just write down this enthalpy change and divide it by 2, and we would get the answer to be minus 3228.2. Now it's not just kilojoules, but it's kilojoules per mole, and that's the final answer we get.